Perform the indicated operations and simplify. While I'm looking at this expression, I'm looking at bases and exponents, and one rule that I want to make sure to remember is that when I am multiplying like bases, I am going to add the exponents. This will be a key rule to remember when solving this problem. I'm going to begin by looking at the first parentheses and squaring it. Now remember, when I square a number, such as 3, I don't do 3 times 2, it's looking at it as 3 squared, which is 9. Now r cubed squared, here's another rule to remember. When you have a power raised to another power, you will multiply those exponents. So in this case, r cubed squared becomes r to the 6th. And s, you can think of that as to the first power. So s to the first power squared becomes s squared. Now I can look at my second parentheses. Well, let's pull out negative 2r to the negative 1 and look at two differences. Negative 2r to the negative 1, this negative 1 exponent is only going to the r. In this case, the negative 1 goes to the negative 2. What I mean by that is negative 2r to the negative 1, the first instance would look like this. In the second instance, I would rewrite that negative exponent on the bottom and still have it go to the negative 2. In this case, we're looking at the first instance. Also, that negative 2, when you square it, remember to square the negative, getting 4. R to the negative 1 squared becomes r to the negative 2. S to the 4th squared, multiply, power to a power you multiply, s to the 8th. Now I can combine like terms, and again I'm going to use this first rule. Well, 9 times 4 is simple multiplication, 36. R to the 6th times r to the negative 2. I'm multiplying like bases, so I'm going to add their exponents, resulting in r to the 4th. And s squared times s to the 8th. Again, adding their exponents, I'm going to get s to the 10th. Now, I didn't need to isolate those exponents, but I did that for you to see each individual exponent. So my final answer would be 36 r to the 4th, s to the 10th.